Sunil Kumar sir, you can start.
Yes, sir. So, very good morning to everyone. I hope I'm audible. Yeah. This is Venkat from Janatics, Coimbatore. First of all, on behalf of Janatics and Farming Technology, we welcome you all to this webinar. We are happy to start our webinar series on this special day of National Technology Day. Together, we will learn many new technologies and enhance our knowledge. We have Mr. Madhujit from Farming Technology to deliver the webinar today. So we have series of webinar planned on this different topics for this month. May 11, that is today, on pneumatics. May 16 on hydraulic. May 18 on advanced hydraulic. May 23 on electrical, and May 25th on PLC. And if you have any queries regarding the session on in the topic, please write in the question box, and we will sure address your questions. Now I welcome Mr. Madhujit to start the session.
Yes, so thank you, Venkat. So I'll just make myself the presenter.
Yeah. Yes.
So is it visible?
Yes, it is.
Yes. So good morning, everyone. So we will start with the corporate presentation. So about FAMIC Technologies. So we are a team of 130 engineers. We are an ISO 9001 2015 certified organization. We were founded in 1986, and we have three main branches in Montreal, Mannheim in Germany, and Pune. So about the in-house expertise, so FAMIC basically works in three main domains. So the first being the software development. So we have a dedicated team of software engineers who basically do all the development related activities. Then the second one is the engineering domain, where we build mostly the catalogs for pneumatics, hydraulics, also for mathematics, electrical systems, and some related to automation engineering. And finally, FAMIC also has a domain known as industrial automation, where we give solutions in PLC, SCADA, and we also give system maintenance. So basically, these are the products that FAMIC offers. So we have the Automation Studio version 7, so that is professional edition. Apart from that, we also have the educational, where it is useful for the students, teachers, and especially for the engineering organizations. Then we also have the versatile, the Automation Studio manifold, where mostly the corporate people develop solutions in terms of blocks and manifolds. So that is the Automation Studio manifold. And finally, we have the ANDON Studio, where we give you solutions regarding automation of small process lines or automation lines in the industries. So these are the products that FAMIC offers. So the objectives of FAMIC is basically to have a long-term relationship with the customer, that is our client. We also give you support in case you are stuck somewhere regarding the updates or regarding the installation. So there is a dedicated team to give you support. We have dedicated representative for each account, and also we give support material, that is on purchasing the software we give you training videos. There are demo catalogs, demo files available, and also the quick start guides for you to refer and work upon. So talking about the Automation Studio Educational Edition, these are some of the milestones that the company has achieved from 1986 to 22. So initially we started with new SIM, the Hydro SIM in the initial years. Then slowly we started upgrading in terms of the customer needs, the requirements, and running as per the time scale. So as of 2009, you can see that we reached Automation Studio version 5.7 with the latest modeling one line diagram, and working upon that. As of now, if you see the 2022, we give you the even web catalogs. So those catalogs are available on the website, and also different technologies like the PLC, Mitsubishi, and faster simulation for larger projects. So we have come from 1986 all over to the current year, that is 2023. So now what exactly is present in Automation Studio? So you can see this diagram. So right from hydraulics to block manifold, then we have the electrical engineering, then PLC ladder logic, we have digital electronics, then the catalogs, we give you the bill of material reports, component sizing. So all this is divided into three main parts, that is simulation, machine documentation, and treat oriented system design. So basically the software fits into multiple programs, as you can see, right from mechatronics, industrial maintenance, electrical, up to marine technology and the automotive technology. So this is the wide range where the software basically fits in. Now, what are the key benefits? So as we saw for the educational version, mostly the students, teachers, and the schools, these are the three main uh, outlets, or these are the three main entities which can take the maximum benefits of the Automation Studio Educational Edition. So students can work upon different exercises. So we will just see in the once I go ahead with my session, even the teachers and the students can also work upon Automation Studio Educational Edition. So apart from this, we also give you the e-learning, that is remote access. So you can access the Automation Studio from your home or school. Now, Automation Studio is present in about 11 different languages and in about 120 countries. So it is being used in high schools, career centers or training centers, colleges, different universities, and also as workforce development. That is, the corporate people use the software to train their engineers. So Automation Studio also uses certain reference books, and those exercises are also available in the Teachware, and different exercises. For example, if you see the first book, that is Anthony Esposito, so different exercises are covered. So these are the interactive exercises I was talking on. So in the Teachware, the students can access different exercises, and there are quizzes they can answer depending on, and they can also generate their reports. So this helps them to understand about the basic concepts used in the software, and they are able to relate it with the actual environment. So now Automation Studio, in the latest versions, you will be able to see the digital twin of your equipment. That is, the actual hardware kit can be represented exactly on the Automation Studio diagram, and you can physically verify the results from your laboratory getting implemented in AS, or the vice versa. So that basically is the digital twin. So there are a lot of illustrated libraries. So I will just show you, like once I start with the session, so wherein you can view different components or the different projects where the actuators or the equipment give you a real-time view of what exactly you see and how that can be represented in AS. So that is what is meant by the illustrated libraries. So the benefits plus the hands-on experience is what you get. So hardware only, that is the hydraulics and electro-pneumatic trainers, and also the hardware plus Automation Studio. So this could be the less expensive option that you might opt for. So if you remember the engineering domain, so here we have worked, our team has worked on different catalogs. So you can see that we have basically different companies. We have agreements with these companies, and we have worked on some of the catalogs depending upon the license agreements. Like for example, Eaton, CKD, Danfoss, SMC Pneumatics, this is UKIN. So these are basically the different catalogs that our engineering team develops. So this is the partial list of clients. So if you consider the, for example, aerospace, Airbus, Boeing, and NASA, these are the three organizations that use the software. If you come to say forest, then we have AGCO, John Deere, Kubota. For defense, you can see L&T, General Dynamics, JCB Defense. And for example, if you see transport, then we have Denso, Honda. So these are basically the different industrial clients, our clients. So Automation Studio educational demonstration. So basically mechatronics is one important upcoming field. So even AS gives you the ability to deal with mechatronics, different mechatronic systems in educational edition also. So we also offer the complementary consultancy services, that is the support. Now also we have the AS Live manifold. So these are the three clients for which we have developed different manifolds, and we also develop the configurators for manufacturers. That is, for example, for Eaton, you can select the part number or the code, and you can just drag and drop this particular product from the catalog. So similarly over here for Hydroforce and Rexroth, we have developed the manifold. So training, maintenance, and services. So this is the support that we can give right from training customer premises to up to the turnkey solutions. So that was it for regarding the presentation. So now we will proceed with the actual session of pneumatics. So now coming to the software. So upon opening the software, basically, so this is the Automation Studio Professional Edition. So if you come to the Library Explorer upon opening the software, so here on the left hand side, you basically have the different modules we work upon. So right from pneumatic, different electrical controls, ladder, electrotechnical, block diagrams, and HMI control panels. So there is also hydraulic in this. So you can just select it like whichever library you want it over here. On the right hand side over here, you have the project explorer. So you can just open this particular project, save it or close it from here. So you have the access over here. On the top, you have the different options, the ribbon, which will have the home tab, edit tab, view, simulation, failure, demo, and the technical training. So you can select different options to work upon. Okay. So now coming to the pneumatic over here, if I just select this library, so here we have the default products or the most frequently used products. So you can see different type of compressor, source, okay, pressure gauges. So these are the frequently used products available over here. So if you want to go for any specific product, so you just have to go over here in this pneumatic module. So if you just click it, you will have a drag down. If you just drag it, so there's a drop down. So you have basically right from compressors up to the different measuring instruments. So you have detailed list and you can select the components as per a requirement. So now we will just build a small circuit just to see like what all things we can do, how we can analyze the circuit in the pneumatic module. Okay, so now I will just take, for example, the cylinder, maybe an electrically controlled directional valve. I will take a pneumatic source. So from the fluid conditioning, I can directly take an FRL. Okay, so I think these are the basic components just to build a small circuit. Okay, so we will just establish the connection now. So now these lines are pneumatic lines, though they appear to be just CAD lines. If you just select this, so this basically represents a pneumatic hose or a pneumatic connection, right? So you have the different properties, so you can change it over here, or you can select or customize it as per your requirement. Okay, so this basically is a pneumatic line. Now to complete this, we will just connect an exhaust, right? So as of now, I've just built this small circuit. Now let us see basically what it does when I start the simulation. Okay, so now before actuating this, if you just select or click on this FRL unit, so as we know that the only property that that can be varied is the setting pressure. Okay, that is the output side, so that is given by the regulator. So you can set it as per your requirement up to 35 bar. So now if I just select this spool, so you can see that the cylinder got actuated. Upon releasing it back, now the actuator comes back and it remains extended. Okay, so this is the one way of just testing whether your circuit is right or wrong. Okay, so now we can configure our circuit as per our requirement and the way we want. So what I mean by that is, now for example, this pressure source, if you just select this source, okay, so there is one illustration over here. So the main properties is the diameter, okay, and obviously you can vary the pressure. So you can vary this pressure or the maximum pressure you want in the circuit, and you can also vary this. For example, if I just change it to 10, so now you will see that my standardized flow will increase because indirectly my area has increased, so it is capable to give me a higher flow. Okay, so in this way you can configure your pressure source, that is the pneumatic pressure source or the reservoir. So similarly for the FRL unit, even here you can change the setting pressure. If at all you feel that the thermal simulation is on, you can even change the heat transfer coefficient and the area. Now coming to this directional valve, so this is a bit more advanced. So here basically you have this spool stroke. Okay, you have the pressure, you can change, you can set the temperatures, that is the range. Apart from this, if you just come to the technical specs over here, so now this offers you the type of command, the type of return you want. Okay, so what I mean by that is, if you just select this solenoid, if you just double click on this, so now there is a list of ISO 2012 standard symbols or the different types of commands available to actuate it. Okay, so as of now we were discussing, or the default I used was the solenoid. So you can even actuate it as external pneumatic pilot. Okay, now there is a two-way solenoid. You can use a push button, you can use a plunger. Okay, you can use some kind of switching knob up to the lever with detent. Similarly is for this, to make it return. Now you can also change the type of spool you want. Okay, so if you just double click on this, double click on the left spool, so there is a list of ISO spools or certain standard spools that we use. So right from this type of, that is all closed connections, up to the open center type or 1 to 3 over here. So you can select the different spools as per your requirement. Now coming to the next tab, that is the area flow. Here you can set the nature of flow or the scale of flow you want through your directional valve. Okay, so the default flow now is 2000. You can use different models, like from no flow model, or if it's defined by an area. Okay, so if I just select this for example, now you can see that this has changed to the area. Now you just have to give the area, like what is your maximum or if it's opening when you come to this particular spool. Okay, then we have the pressure line model, or if it's model defined by flow curve, then pressure line model defined by the flow curves. So basically these are different methods in which you can set the openings so that on actuation you will get the particular result. Okay, so this is the pressure drop curve. So in case it is an orifice model, these are by default. In case if this is a user defined curve, for example, if I just make these as user defined, that is you can enter any point. If I just select apply, then the pressure drop curve that can also go as user defined. Now you can see that I can enter the pressure drop value that I want. Okay, so this is how you can configure different products in Automation Studio. Now coming to the cylinder, I will just show you one important feature over here. For cylinder, if you refer this again, the data properties, so it is a big list, so you can configure different properties. You can also give the force curves in case you want to test it with say resistive force or driving force curve. So you can enter the resistive force value, okay, or you can enter the driving force curve value over here, then you will get the result. Apart from that, we have the builder. So now the default apparent length is 4. Now for example, if I have two circuits and I just want to show you that one of my cylinder serves a bigger stroke or is larger than this. So if you just enter the data, you won't be able to physically verify it. So just to ensure that it is slightly big, so you can select the builder over here. Now if you just try to increase the say apparent length to 6, now you can see that this cylinder has the dimension has increased, and you can see that my new apparent length is bigger than this in terms of the CAD. Okay, so now this was about configuring the different products. Now we will see how to analyze different properties when you're in simulation. Okay, so now if I start the simulation, for example, if I want to find out the pressure or flow values, okay, or the type of stroke or how exactly this works. Okay, so for this there is component dynamic measuring instruments available in the measuring module of the simulation ribbon. So here if I just select this, and if I want to measure properties of the cylinder, for example, okay, so if you just select this and just drag and drop it, so it will now offer you the different properties that you can measure. Okay, so for example, I want to say measure the linear position of the cylinder. Okay, so the displayed unit has different units, so you can select it as per your requirement. So I will just keep it as mm. So there is a precision up to what you can go. So for example, I will select 0.01. Okay, so you can also record these values in simulation, and then later you can extract it. Okay, so now I am going to record this. Now to see the results, basically where they are being generated, so we will just select one y of t plotter. So now you will see that a small screen appears like this. So I will just drag and drop this particular property over here. So now you can see that the length, if you remember, I had selected the position. So now length versus time. Since this is y of t, so length versus time. Now the scale is ready. Now when I start the simulation, and if I actuate the cylinder now, you can see that now if I just pause it, or if I just stop the simulation, you can see that initially my stroke was 250 because it was fully extended. Now when I gave the actuation, it retracted, so my stroke fell to 0. Okay, now from this we cannot exactly find out exactly what the timing of the retraction was. Now if I want to do a small calculation and an analysis, so obviously I will just connect a small needle over here, or restrictor basically. So we will just take the fixed throttle. Okay, so now you can see that. So let's set this to say 0.5. Okay, so if I were to just release it, now you can see that my cylinder will start, I mean, extending back. So if I were to just freeze it now and just take this cursor and just adjust it, so it is 0 over here. I'll select another cursor, say over here around 250. Okay, so you can see that the delta t is approximately 4 seconds. So now I can try to find out the velocity. Like this was the distance upon time. So this is the average velocity. The slope will be the average velocity with which my cylinder got retracted. Okay, so in this way, you can analyze different circuits using plotters. Okay, and this will help you to the students and even the technical people to find out like how precise or the results given by AS are same as the calculations that we can physically do. Okay, now before proceeding to the next part, I will just make a small connection, electrical connection to actuate. As of now, I just actuated it forcefully. That is, we just tried to extend it manually and I retracted it. The reason I'm showing is in the next slide, you will be able to understand, or the next diagram that I will show you, you will be just able to understand like why I'm trying to do this over here. So I'll just build a small electrical circuit to just show you how to do the variable assignment and what is the exact need to do that. Okay, so I will just take the electrical 24 volts and 0 volt over here. I will take a normally open push button and say I will say just call it by a name PB1. I will take a solenoid coil. You can name it by any name of your choice or whatever you prefer. So we have just taken a coil that is a solenoid and just a push button. Okay, now this coil is nothing but the wiring of this one. Only we are representing it in terms of the electrical connection. So to make this equivalent to this, we have to do the variable assignment. So what is that? So if you just select this solenoid over here, so here if you come to the variable assignment, now what is the variable name to be linked? So that is the SOL1, right? Whatever name you have given. So if you just type it over here, the compatible simulation variable will appear. So just select it and do the variable assignment. It says create a read and write association. So now I have done the variable assignment. So if I just start the simulation now, okay, and if I just give the PB1 or push button, you can see that basically this solenoid is getting triggered electrically by this push button. Okay, so this is the concept of variable assignment. So in this way, students can even integrate different electrical technologies or do different sequencing and link it to their pneumatic circuits. Okay, so this was a small basic example. Now coming to the part that we were now interested. So we will basically see like what are stack wells and manifolds. But before that, if you see now here, I had to do different connections by myself, right? So this is even in if you do this in your laboratory, you'll have to connect one hose from this port to this port, again an orifice over here, again establish a small connection, then again from here to the cylinder. So you have the blue, mostly the blue color pneumatic lines, you go on connecting. Now what to do in case there is different compact applications where there is a constraint of space? So in that case, we go for the stack valves or the concept of manifold. Okay, so that basically eliminates the need of a lot of pneumatic hoses. So now if I come to this, okay, so what we have over here. So initially, before going to this part, so we'll just place this over here. Okay, so now this basically is the directional valve. So this is 5/2. Earlier we just saw a small example of 3/2. Okay, so this has different input lines, and this basically is a kind of a manifold block. Though the connections are different, this is a bit slightly advanced to what we saw. So here basically you have the 513, 51 and 3. So these two are mostly the exhaust ports. Port 1 is the input pneumatic port, right? We can change the positions depending on the solenoid and a pilot over here. So this is basically an electro-pneumatic directional valve. It requires the electrical connection also. So for this, we will do the variable assignment just we saw. Okay, and this we will just see how this directional valve will now operate. So now how to do the connections. Now I will not, for example, I will not connect it like this, like the earlier part. So in mostly we make use of the different manifolds that we have already built. So now, though these lines are pneumatic lines, but the manifold block will not have a pneumatic line. It is a type of a casting that is done. Okay, and it has different manifold ports, and air flows from this particular input port via this chamber to the port 1, because this is the same line. So to connect this, for example, you just select this manifold. Okay, just align the ports and just drop it over there. Okay, so now what happened? This port 1 got connected to the port 1 of the manifold. Okay, and these two 5 and 3, the exhaust ports, are now connected to the exhaust ports of the manifold. So we have just placed our directional valve block on the sub base, that is the manifold over here. Now if I want to actuate this, obviously I will have to give a source. Okay, so you can see that I have a source over here. So I'll just place it together at this particular port, that is port 1. Now my pneumatic source via this regulator is now available at port 1 and can be used over here. Correct? So this is done. Now before connecting this, we will just see like what happens over here. Now if I just select this cylinder as an actuator, and now for this I will have to make the pneumatic connection. So I will just connect it like this. Okay, so we are taking the input air, and now depending on the actuations, I will be giving it to port number 2 or port 4 of the outlet. Okay, so if I just start the simulation, so now initially what happened, the moment I connected this, the air is now available from this port. It went to this cylinder, that is port 2, and my cylinder got actuated. Now if I were to retract this cylinder now, okay, so if I just, for example, select this particular spool, okay, so now you can see that air is available over here to this port. Now there is only one small thing which we missed, right? So that is basically the exhausts. If you see, there is no particular exhaust. That is why air is available from both ports. So we will just quickly connect the exhausts, right? So just rotate this. I just place it over here now. Correct. Now if I release this, you can see that initially it was over here. If I connect this, you can see that my cylinder gets retracted. Right. Now if I were to use this again in terms of the variable assignment, and like we discussed, okay, so only thing is that if I were to make, for example, a small electrical connection quickly now, so we will just see like how this will work. differently in this case. So if I just go to the electrical control, just take this coil now and just build it quickly and say limit SOL2 124 volt and say it normally open push button. Say call it PB2. Now there is one interesting thing in this. Now initially we tried to do it forcefully, that is I just selected this pulse. In this case there will be a slight variation, so we will just see what that is. Now I connect it to 0 volts. So now again the same step. So this solenoid we will link it to SOL2. Okay, so now this is linked. Okay, so now if I start the simulation, okay, and if I try to give PB2 now, you can see that this system will not work. Why? The reason being, now this solenoid is not just sufficient to actuate this like the earlier one, but here we have some pilot also. Okay, so it requires a pilot force also together with the electrical solenoid to actuate this valve, Okay, so now if I were to give pilot at this particular port, okay, so as of now I will just select this line. I'll just connect it to say 1,4. Okay, so you can change the nature of this line. So I'll make it pilot line. Now let's see what happens. Okay, so now you can see that my system, I mean basically my directional valve is now functional because I gave a pilot. The force was already there. Now apart from this, when I give the electrical solenoid actuation, then only my system will work. Correct. So this is how earlier we discussed the variable solenoid 2 is linked, and it makes use of this pneumatic pilot to actuate my system. Correct. So basically this advantage of this is to reduce the connections, because you just saw that I took entirely all these with inbuilt manifold connections. I just made these two and this. So this is how it will, the people from software or people from companies can work on different manifolds, and it helps you to save a lot of time and efforts. Okay, so now we just saw this. So if there is a different requirements, now I will just remove this particular thing. I just remove this actuator. So these are basically what we call as stack valves. So initially, if you have a requirement of metering meter out, or if there is a pilot to open check valve, or even if there is a regulator, so you can just go on stacking it as per your requirement. And finally, in the end, you build your actuator. Okay, like for example, over here, so this will be, for example, at the bottommost plate. So before this, if there is any need of say metering concept, so you just stack it below. If you want, there is a need of a pilot to open check block, so you can just connect it like this. And if you have to maintain a regulated pressure at output of at the port 2, so then you can even make use of this particular port. And finally, you can use either this manifold, or in case if you want to connect 1,4 via a different external supply or source, you can even make use of this particular manifold. All right. Now, in case if you want to end these connections over here, or it means that there is no outlet or something available, so even you have the end plates, so you can just put your end plate over here. Okay, so only in this case 1, 3 and 5 will run further. Your pilot ports will stop because there are plugs inserted. So in this way, you can even build different types of end plates, And suppose there is a case that, for example, now, just a second, suppose there is a case that you have different types of stack valves. Like for example, I'll just move aside this part, and suppose there are two manifolds like this. Sorry, there are two manifolds like this, and on one part you do not want any stack valves. I mean, you just want to keep it blank. So we have the cover plate or the top plate. So you can see that all ports are plugged. So you can just place it directly on this like this. It means that my input connections are only available to this. They are blocked over here. Correct. So in this way, you can build different stack valves. So now we will quickly see how to go about the manifolds. Correct. So now if you see, this is one type of a manifold from Norgren. So my teammates were currently working on this. So they just built a small circuit representing this exactly over here, right? So this is the master on-off block. So it has been built over here. You can see these four solenoid coil blocks. That is the directional control valves, which are solenoid operated. So we have placed it over here, and below you see a manifold on which these are mounted. So this basically is that manifold. If you just refer the drawing over here, so this has been built over here. Okay, so now this basically together is a manifold block, unlike the earlier one which was in terms of stack. Here you just keep the directional valves directly on the manifold. Okay, so if you just start the simulation, and if you just select the different solenoid coil, you can see that my cylinder 1 now works. Similarly, the cylinder 2, I'm just giving the electrical connections. Now, if I just give 3, right? And if I give 4, and if I try to give this one, that is the main on-off valve, I can only actuate the final cylinder at the end. So in this way, you can build different manifold behavior logics. You need only minimum connections. I have done only to the cylinders. The rest all connections are within the manifold itself. Okay, so in AS, you can also build different modules like this, the one available in your lab or the actual industry products, right? So this was about the manifolds, the stack valves. Now coming to the next part, as Janatics is, we have done the catalog for Janatics, and it is also in our main client, and also we are in collaboration with Janatics. So we have built the Janatics catalog. So this is basically the catalog manager. Here we have the different products that Janatics has built, and we have done the catalog. So the different cylinders, okay, the directional control valves, the airline valves, air preparation units, and the different accessories. Now, what I mean by this is, suppose if I select this particular product, that is ISO 6431 thyroid cylinder, okay. So now this basically is the catalog manager, okay. You can see that now this image is the actual Janatics built product, okay. So now we have modeled it in AS referring to the exact specifications given by Janatics. So what are those? If I just go into the data, so now these are the data properties that are the product has been designed by Janatics. So for example, the cushion length is 21, or say piston diameter is 32, or the stroke is 25. The temperature limits for this particular product is say 5 to 60. So if I were to select now the configurator over here, okay, so now you can see the different properties that I can select. Okay, so the model, whether I want a magnetic or non-magnetic. Suppose I will select a magnetic cylinder. The stroke is from 32 to 100. Suppose if I select 100, stroke I will select 500, and I will say select now the basic. So you can see that one part number has been generated. If you visit the Janatics website, you will find that this particular product is available. Okay, so that is what we have built it over here. Now if I just configure this, okay, you can see that my cylinder is now as per the selections I have done. So if I just drag and drop it, okay, now this particular cylinder, unlike these, now this stands to the exact dimensions that have been considered or given by Janatics. Okay, so this is basically the difference. The initial cylinder that we saw over there, the double acting and here, unlike that, this confirms with the standards as per Janatics, whatever they have given. So that is why this is what is the importance of catalog. In catalogs, you can create products depending on the specific requirements. Now, if I just were to visit this cylinder, now the data properties cannot be modified, okay, because they have been locked. Now you cannot change this. You can configure it in the catalog and you can use this as a standard product for your project, which has been done according to the Janatics or their standards, right? So this is what is about the Janatics catalog. So unlike we have different products, so this was just a simple example of cylinder. You can go for different directional valves also, different types of valves, filters, regulators, FRL units, etc. Now coming to the next part. Now we also have some demo catalogs and we have some nice projects which will help you analyze what exactly is the need of AS when it comes to the actual field. Okay, so now if I were to go in this pneumatic module of the demo, so now I will just show you a small example of a gripper, how new how we have developed a small gripper using pneumatics. So this will help you understand like how you can actually model and design your system. Okay, so I'll just wait for this project to open. Yes, so now you can see a small circuit that has been built. Here you also have the mechanism viewer. Okay, so this is the mechanism for this particular gripper. So if you would just start the simulation now, right? So now if I just actuate this, right? I think it is already extended. If I just give this, you can see that the gripping action has been done, right? Now the ungripping action is being done, right? So you can see the gripping action and you can see the ungripping action, right? So in this way, you can build the pneumatic circuit and you can also create the equivalent mechanism. You can create links using the mechanism manager in Automation Studio. Okay, so this is one small example to understand like how pneumatic circuits can be used to build different applications. Okay, so now there is also another example. So we will just close this project. So there is another example of sequencing. So I will just present it to you how you can do the sequencing. Or I can show you the example of okay, we will just see the sequencer example. So basically this is the demo catalog that we also build, unlike the Janatics catalog. So this is for the demonstration purposes. So this is what we call it as a demo catalog. Okay, so you can see the complexity of this particular project. All right. So there are instructions. So this has been built. I mean, this is basically written in French, but you can see the complexity. It makes use of different modules to actuate this. Right. So let's see how this simulates. So you can see that different cylinders are now working in progression. We started from this topmost cylinder 5 up to the cylinder number 9, right? Correct. So if I were to restart this again, you can see that it starts from the cylinder and it comes to the cylinder number, I mean the last one over here, right? So this is basically an example of sequencing right from the cylinder 5 up to this. So in this way you can even build complex circuits. The students can be able to build it using the roller switches and make use of that logic for the next one. In this way you can go on building the required sequencing, right? So this was the second example. So now coming to the last part. So that is basically the uh, ANDON studio. So now Saurabh will just tell you like what exactly is the ANDON studio, why we are doing that, what is as per the complexity of the market. It is necessary to integrate and have smart solutions to manage the workstation, the order. We can calculate the time needed. The Andon Studio also gives you the required results to monitor in case you're lagging or leading somewhere. Okay, so all that things are covered in a different software called as Andon Studio. So Saurabh will just tell you like what that is in a very short and a crisp way.
Yeah, I hope my screen is visible.
Yes, yes.
Yes, so Andon Studio is more related to Industry 4.0. Okay, so basically it monitors the real-time data. Okay, so it is mostly used in industrial engineering, then operations management, business processes, and quality. Okay. So what are all the features covered in ANDON Studio? You can see here. You can also see these features in our website. Okay, you can just go to products, and in the ANDON Studio you can find professional edition and education edition. Okay, so for the educational purpose, if you want to see, you can just click on educational edition, and you can see all the features. Okay, like it has some features like data acquisition, service request management, real-time production operation monitoring. Okay, then workforce management, IoT, then alerts and notifications, right? Inspection and quality, then custom reports generation. Okay, so categorization and access to documentation, data logging. So all these features are available in Andon Studio. So if you want to see the brochure, you can just go to product brochure, and you can select the language. Okay, and you will find here. So if you want, yeah, so you can find more detail. Yeah, and if you want to have a detailed demo on it, so you can request us anytime, and we can arrange a small demo for you. Okay, on Andon Studio.
Yeah, okay. Thank you, Saurabh. So if there are any doubts regarding the session, so you can just uh, post it in the question box. I think yes, there is one question. Uh, Saurabh, can you just? I'm not able to. Yeah, yeah. I think there is one question by
Mm,
how we can build our own manifold. Muthukum, I think, is asking this question. Also, in our practical application, the tube connection play important role on friction. Can we define the length of tubes in simulations? Yes, so that can be done. So, Saurabh, can you just make me the presenter?
yeah.
Yeah, yes. So, if I just go to the manifold or the stack, for example, right? So here, for example, if I select just or to go on this, so this basically is the manifold that we have done. Okay. So now if I want to, change the property of say or the length within the manifold, now, for example, I will just disassemble it because, this basically is an assembly of lines. So I will just disassemble this. Okay. So now these are actual lines that we initially saw. Okay. If you just so select this, now if I were to unlock the properties, so here you can select the different type of line, okay, which different diameters with different lengths. You can change the diameter if you were, I mean, if you just select this feature, for example, now you can change the internal diameter length, right? You can change the heat transfer coefficient. Only the cases for pneumatic lines, friction is not that important because pneumatics will have uh, flows for automation. We mostly make use of automation, so we do not discuss friction loss. So that will be mostly in hydraulics. But yes, you can change the different properties, different lines, lengths, okay, and even the material is available. So that can be configured in AS. So that is right. Okay, I think Mustafa is asking that there is a lot to learn in this Andon friendly user. Yes, I think we can organize a separate demo for this, and even Andon cannot be covered in 5 to 10 minutes, so it will need time. And you can see that it will help you to analyze different concepts related to some kind of automation or a production line. So that is user friendly and it works similar. I mean, it basically uses the industry 4.0 concept, to work upon. So I think that answers the question. Will this recording be available? Yes, I think this is being recorded, so it will be available. Maybe this recording, we can send this link to you, so you can just revisit it. Is software free for students? I think Saurabh, we have to. Do we have any provision for this?
No, they have to purchase the licenses.
Yes, so I think upon purchasing the license, we also give you the you can access the Teachware and the different things. So it is not available for free as for free. Would it be possible to recording? Yes, we will provide you the recording link so you can revisit it and watch it. How long to master all the simulation? No, if you know the concepts, I mean, of pneumatics or hydraulics, I think you can. I mean, mastering is related to different, technical properties or those things. So if you know the basics, I think about 3 weeks is, I think, will be more than sufficient to understand all the basics. So I don't think it will, need more time. Okay. Can you also share the future seminar links to our colleagues? Or yes, I think, sir, the links are already shared. Probably also, as discussed initially, sir told that we have upcoming demo. You can just note down the dates. I will just read it out once. So we have one more hydraulics webinar on 16th. Okay, 16/5. Then advanced hydraulics on 18/5. Then we have electrical demo on 23/5. And finally the PLC on 25/5, that is 25th of May. Okay.
We can do one thing. I will share the webinar invitation once again with him.
Yeah, sure. So that will be available to you. I think, Saurabh, there is one question. What is the price for? No, before this, is the software be used on Festo parts? I think, sir, we also have Festo catalogs. So we have built, products, like for example, the cylinder. We have built Festo configured products in the software. And I think this software is more versatile than Festo in terms of the different compatibilities in terms of CAD, the simulation lines and all. But we can, yes, we can work on the Festo parts also. Then I think, what is the price for 20 users? So we can just answer this. Can it be used to control lab pneumatic components? Yes, for lab pneumatic components, you can make use of, a hardware like the IO box. Only it should have a compatible driver, and you can link it to your laptop, or via the software. You can test the pneumatic components from your laboratory using soft PLC, that is the AS. So that can be done. So Saurabh, like, what is the price for 20 users? So I think that is what they are asking.
Uh, yeah, we will get in touch with the price. Okay, for the price.
I think Patrick was asking that question. So Patrick, you can just drop an email to Saurabh, or you can just raise a query on the website so we can answer that question. Yeah, I think
we will contact them.
yes. I think there is one more question. I think when the demand on application becoming low, need to get latest. Yeah, I think Automation Studio is more user friendly, and it doesn't take much time for you to grasp the concepts. So I think that the software can help you master and even apply it. The students or even the engineering professionals can apply the concepts very easily, like unlike what I just showed in this session. So I think it is not that complicated, though it seems to be. Okay. Any application simulation on open source? No, I think we have a lot of demo files basically. Okay, so you can we can organize a different demo on this just to show you uh, the connections. If you just remember the very first circuit that I built, it was just a simple, single acting cylinder circuit. So right from that to the concept of manifold and even beyond this. So I think there are a lot of demo files that are available, but due to the time constraint, I just showed you only two of them. But I think there is a lot of developments done in that. How does it compare with Festo's fluid sim software? I think in terms of the, like for example, if I were to just start the simulation again, or if I revisit the very small first circuit that I built, and if I just start the simulation now, okay, so all this like dynamic measuring things in terms of the plotter, okay, so I think this Festo will not be able to generate much of this. Even the for hydraulics, it could be, it could be explained to a much larger extent, because even the color of the fluid lines changes depending on the pressure. It can monitor up to like very fractions of a seconds we can get the accurate results. Mostly I think I just showed you the different types of spools, the area flow curves. If you visit the pneumatics, the range of components, and the different technical properties, I think it is, I think I would say it gives you a wide range in terms of simulation compared to Festo. Okay. Uh, my question is, do you provide support for internship plus final? Sir, I think we give an opportunity to MTech students for internship also. I think I'm not sure about projects, because projects are something to be built. But if I were to tell you about my experience, I uh, built my MTech project on this software itself, because I had built a pick and place robot, and it sorts it as per the different colors and places in the racks. So I made use of this automation studio as a PLC, because I could not afford the actual PLC, because it costs you a hell lot of money. uh, but I don't know, like we are not giving projects, but we give internship opportunities to students, if at all they are willing to work over here. So I think that was the last questions. If there are any questions, please post it, because I think we are running short of time. Okay,
Okay.
I think someone says like you may continue. I think Mustafa is saying, no, I think these are the concepts. I think I am done from my side. Only thing is, uh, how will be going to get internship? So I think maybe Saurabh or my colleagues can answer this, because we had two colleagues earlier for internship. So maybe Saurabh, you can just answer this, how we will get the internship.
Um, so basically, uh, if we are providing internship, definitely we will contact you. Okay. So currently I am not aware of aware of this. Okay. So I will let you know. So I guess we can end here. Sunil sir, you want to say something?
Yes, sir. So finally, we are at the end of today's webinar. Hope everyone is good with the session. So for any queries related about our products and like inquiries, you can please visit us at janatics.com, or you can undersign the given mail ID. So we have a series of webinar planned on the upcoming days. So next webinar is on 16th May. The topic hydraulics. For every session, we have a separate registration link. We request you all and your peers to register and bring into play. Thank you.
Yeah, thank you so much.
Thank you, Venkat.
Yeah, thank you everyone for joining the session.
Yeah, thank you.